So I will take a problem on coplanar concurrent force system. So you can see here there are three forces given: 40 Newton, 20 Newton at different angles, of course, acting at a common point O. That is what is called as concurrent force system. So the resultant is acting vertically downwards. That is also he has given. Now he has asked what is the value of this alpha and also the resultant R. So first what you have to do here is we have to resolve the given forces. There are three forces here into x component and y component. So x component is in this direction, y component will be in this direction. So if you resolve the forces, this 40 Newton force doesn't have any y component. This 40 Newton force, if you resolve, since alpha here is with respect to vertical, this will be 90 minus alpha, and if you resolve this along horizontal x direction, it will be 40 cos 90 minus alpha, this will be 40 sin 90 minus alpha, or in other words, I can write like this: if you resolve this 40 Newton, the components will be like this. So this becomes 40 cos 90 minus alpha means 40 sin alpha, this becomes 40 sin 90 minus alpha means it is 40 cos alpha. And similarly, if you resolve this 20 Newton, x component will be towards left, y component will be downwards. So the components will be 20 cos alpha and 20 sin alpha. Now once you resolve that, the forces, we will write sigma fx. Sigma fx is the sum of all the forces acting in x direction, taking forces acting towards right positive. So there are three forces here. This 40 Newton is acting towards right, therefore it is plus 40. And the component of this 40 Newton is also acting towards right, and it is plus 40 sin alpha. And 20 cos alpha is acting towards left, so minus 20 cos alpha. So this is the value of sigma fx. Similarly, if you write sigma fy, algebraic sum of all the components of forces in y direction treating upwards positive, downwards negative. This doesn't have any vertical component because it is horizontal, and this vertical component of this 40 Newton is minus 40 cos alpha because it is downwards, minus cos 40 cos alpha, and the vertical component of this is minus 20 sin alpha. So first step is to resolve the forces, then take the algebraic sum of the forces both along x direction, y direction with suitable sign convention. For x direction, forces acting towards right positive; for y direction, upward forces positive. Now he has given that the resultant R is acting vertically downwards. You can see the figure. Since it is acting vertically downwards, as we know that the resultant force in general, it is resolved into two components: sigma fx along x direction, sigma fy along y direction, with some angle alpha or theta made with the horizontal or x axis. Now according to this, in this case, since R is acting vertically downwards, this R itself is equal to sigma fy, and another condition is sigma fx will be 0. Suppose in any problem if they give the resultant force is acting along x direction, then we have to take R is equal to sigma fx and sigma fy will be 0. Now these two are the conditions which we have to follow to solve for alpha and R. We will be having two equations, we have to solve those two equations. Now let me apply the first equation. The first equation states that R is equal to sigma fy. Now since here R is acting downwards, sigma fy also will be downwards, because that's why both these two terms they are negative. Now I will remove the negative sign. So R is equal to this downward sign indicates the negative sign here. That is 40 cos alpha minus plus 20 sin alpha. So this is the value of R now. I call this as equation 1. Now if I use the second condition, sigma fx is equal to 0, Now sigma fx, what we got here is 40 plus 40 sin alpha minus 20 cos alpha. This should be equal to 0. Now if you simplify this, dividing throughout by 20, so you will be getting 2 plus 2 sin alpha minus cos alpha is equal to 0. Now this is a trigonometric equation in sin and cos. Therefore, to solve such equations, to get the solution of such equation, we have to bring one trigonometric function to other side. That means LHS one function should be there, RHS another function should be there. Then we have to square it. Then we have to use the relation cos square theta plus sin square theta is equal to 1. Then you get a quadratic equation in either sin alpha or sin or cos. Then if you solve that quadratic equation, you will be getting two values for alpha, out of which one value will be valid. So that is the procedure. Now what I will do here is this 2 plus 2 sin alpha is equal to cos alpha. I can write like this. Now we can square both sides. Squaring both sides. So this is the usual procedure for solving a trigonometric equation which contains both sin term and cos term. So if you square both sides, 2 plus 2 sin alpha whole square will be equal to cos square alpha. In other words, this 2 you can take outside and square of them will be 4. So 4 into 1 plus sin alpha whole square is equal to cos square alpha, or in other words 4 into a plus b whole square formula I will use. A square plus b square, that is 1 square plus, that is 1 plus sin square alpha plus 2 sin alpha. That's what you get, is equal to cos square alpha. Now I can just multiply this, so and reduce to a trigonometric quadratic equation. 4 sin square alpha plus 8 sin alpha plus 4. This is equal, this cos square alpha will bring this side, minus cos square alpha is equal to 0. Now this cos square alpha I can write as 1 minus sin square alpha. So once again if you simplify that, so this minus will be there here. So this minus into minus becomes plus 4 sin square alpha plus 1 sin square alpha into 5 sin square alpha, and here plus 8 sin alpha. 8 sin alpha, then plus 4 minus 1 will be plus 3 is equal to 0. So this is what we get. Now you can just see that this is a quadratic equation in sin alpha. You can compare that with this equation ax square plus bx plus c is equal to 0. So where a is 5, b is 8, x is sin alpha and c is 3. So the solution of this quadratic equation is x is equal to minus b plus or minus square root of b square minus 4ac divided by a. Now therefore by substituting these values you will get minus 8 plus or minus square root of 8 square minus 4 into 5 into 3 divided by 2 times a is 5. So that is minus 8 plus or minus root of 64 minus 60, that is root of 4 which is nothing but 2 divided by 10. So you will be getting one value, of course is negative. So which is minus 8 plus 2 means minus 6 by 10. Another, that is another value, it is minus 10 by 10. So that means you will be having x is equal to minus 0.6 or minus 1. So these two are the values we are going to get for x. So now you can just see that once that is x is we know that it is sin alpha, x is equal to sin alpha, therefore sin alpha is equal to minus 0.6 6 or minus 1. So you will be having two values of alpha here. Of course, let me take the modulus of this. So therefore, sin alpha is equal to 0.6 or 1. You can take. So if you use the modulus, you are going to get alpha as sin inverse of 0.6 or sin inverse of 1. So here sin inverse of 0.6, I think it is sin inverse of 0.6 is 36.87 degrees. 36.87 degrees, or it can be 90 degrees. So these two are the options because sin inverse of 1 is 90. Now among these two, if you observe the diagram, alpha cannot be 90. So therefore, what you can say here is you can take that alpha as 36.87. If you take alpha as 90, then what happens? The forces, this 20 kilonewton force will be acting like this, 20 kilonewton force will be acting like this, and this 40 newton force. So this will be, this is with respect to horizontal, therefore it becomes vertical. This is with respect to vertical, therefore it becomes horizontal. So 40 will come like this, and already another 40 is given in the direction only. So you can see that this will be the case if alpha is 90 degrees. So this, when this is the case, then the resultant will not be acting in this direction, definitely. So resultant will be something like this. So therefore, this case we cannot use. So the other value is alpha is equal to 36.87 degrees. This is valid because alpha is acute angle according to this diagram. Now once alpha is 36.87 degrees, this value, so this value you cannot take. Substitute that value of alpha in this equation for R and simplify, you get the value of R. So resultant R is equal to 40 into, so substituting in equation 1 for alpha. So 40 into cos alpha, that is cos alpha, plus 20 into sin alpha. So 40 into cos of 36.87 degree plus 20 into sin of 36.87 degree. So it comes out to be, so you can calculate that 40 into cos of 36.87 degree, which is 31.2. 31.99, that is 32 you can take, plus 20 into sin of 36.87 degree, which is 12. So that is finally you get 44 Newton. So 44 Newton is the resultant force acting vertically. So this is the correct answer. So that means in this problem we have got two values for alpha because we got quadratic equation in sin alpha, but out of that only one value of alpha is valid. So the other value of that, for that value of alpha we have to get the value of R. The same problem can be tackled by converting this equation into a quadratic equation in cos alpha also. In that case, what we have to do is the sin alpha term we have to retain in the LHS. This cos alpha term and this 2 we have to bring to the RHS, squaring both sides. Then we have to express this, we will get sin square alpha term. So you have to express sin square alpha as 1 minus cos square alpha. You will be getting a quadratic equation in terms of cos alpha. Two values of alpha there also you will get the same answer. You can just check that. So whatever equation you get here, final answer should be same. So alpha you are going to get same answer even if you take the quadratic equation in terms of cos alpha and solve. So this is an examination problem wherein so we should know how to resolve the force, how to calculate the algebraic sum of the force, how to use the concept of resultant. So as already told, if the resultant is acting vertically upwards or downwards, you have to take r is equal to sigma fy and sigma fx will be 0. Suppose if in any problem if they give the resultant is acting along x-axis towards right or towards left, then you have to take sigma fy 0 and r is equal to sigma fx and we have to proceed.